So let's talk about electrical concept like amperes, voltage, watts, kilowatts, kilowatt hour. Okay, amperes, which is also shortened as amps, is a measure of electric current. Okay, so amp or amperes is the unit for measuring electric current. Now there is voltage. Sometimes people confuse voltage and current. So what's the difference between voltage? Between voltage and current? So what's the difference between voltage and current, and how does the two of them affect? So voltage and current, the two of them together determines the amount of power a system has. So if we are looking at a system that produces power, the current and the voltage determines the power. If it is a system that is connected to power, meaning it consumes power, the voltage and current determines the amount of power that it will draw. So what it means is that if you want to calculate the amount of watts that a particular device consumes, then you calculate the voltage and the amp of that. You multiply the voltage with the amp and it will give you the wattage. So for example, if you have a device that is rated as 6 volts and 10 amps, 6 times 10, it gives you 60. Okay, so it means that device consumes 60 watts. Simple. If you want to calculate the wattage, the kilowatt hour of a battery, all you need to do is multiply the voltage with the current. So if the battery is rated as 12 volts, 200 amps, then you do 12 multiplied by 200, which is 2400. Now it means that battery is 2400 watts, which is the same as 2.4 kilowatts. Okay, so it means it's a 2.4 kilowatt hour battery. Very simple and straightforward. So once you know these things, you know it, you know how to apply them, you know how to use them, you know how to design a solar power system. So let's look at what's the difference between watts and kilowatts, then kilowatt hour. Watt is a unit of measurement of power. Kilowatt is just the same thing as watt in thousands. So kilo stands for 1,000. So kilowatt means 1,000 watts. Okay, 2 kilowatt means 2,000 watts. Okay, so kilowatt is just the same unit of measurement, but now in thousands. Okay, so kilo stands for 1,000 units. Okay, that's the meaning of kilo. Then what is kilowatt hour and how does it differ from watt and kilowatt? Okay, so watt is an instant measure of the amount of energy, or the instant measure of power, or instant measure of the energy that is being consumed or produced by a system. Okay, while kilowatt hour, kWh, is a measure of energy produced or consumed over a period of time. Kilowatt hour is a unit of energy which is equivalent to 1 kilowatt of energy that has been consumed in an hour time. Okay, so let's talk about circuit breakers. Okay, so circuit breaker. So what is a circuit breaker? So a circuit breaker basically is a piece of electric device that is designed to stop the flow of current when it detects excess voltage, okay, or excess current. A circuit breaker is a piece of electrical device that's designed to automatically switch off to stop the flow of current when it detects excess current or excess voltage. So there are different types of circuit breakers. There are AC breakers, there are DC breakers. So there are breakers that you can set how you want it to work. There are breakers that you cannot set, that has been preset, it has been pre-designed from factory and it has rating, so you use it just like that. So this box right here, this is an enclosure for a breaker. Okay, so this is an enclosure for a breaker. So what I have right here is an adjustable voltage / amp protector, meaning that we can adjust the voltage and current, the amount of current that we want to pass through this breaker. So like I said, there are some that are adjustable that you can adjust, while a lot of them are not adjustable. So some have been pre-designed. They have been built from factory to handle a certain amount of current or voltage. So if that's what you want, you buy that one. Then while there are some that you can program on your own to give you to do exactly what you want it to do. Okay, so during the practical training, so we'll learn how to use these things, we'll learn how to connect them, we'll learn how to set them manually, the one that needs to be set, then the one that has already been set from factory that doesn't need setting at all and doesn't have a way to set it. So we also learn how to use them, how to connect them, and that. Okay, so moving away from that, I want to talk about earthing/grounding. So what is earthing or grounding? Earthing or grounding is the process of connecting your electrical devices to the ground so as to dissipate excess electrical current to the ground. So where is the excess electrical current coming from? So when there is thunder strike, lightning strike, or faults from the power station, sometimes it can send excess electricity. So when that happens, your grounding helps to send the excess current to the ground, thereby preventing your electrical system from being burnt up and also preventing the users from being electrocuted. Okay, so there is something called thunder arrestor or lightning arrestor. Now, how does lightning arrestor differ from earthing and grounding? Now, the two of them are similar but work in their own ways and must not be used interchangeably, meaning you must not use the earthing to do the work of a thunder arrestor, neither should you use the thunder arrestor to do the work of earthing. So like I said, that the earthing/grounding, what it does is that it helps to send excess current to the ground to prevent damage to system and also to prevent electrocution of the users. Okay, now, and I said that this excess electric current, it happens as a result of thunder strike, lightning actually. Lightning is one of the things that causes excess current. So then, if lightning is one of the things that causes the excess current, and then the earthing/grounding helps to send this excess current to the ground, the question you might want to ask is, so what's the point of having a thunder arrestor again if the earthing is doing the work? When earthing is installed in your house, what it does is that it's sending the excess current that is coming from the national grid, or the excess current that happens as a result of the fault that is coming from the national grid, or a fault that happens right there in your house. So it stores the excess current, it sends them to the ground. But then if there is a lightning strike in your neighborhood, your earthing/grounding does not have any business with the lightning strike in your neighborhood. It cannot send the excess current, the current that is generated by the lightning strike in your neighborhood. What's the difference between earthing/grounding and the thunder arrestor? Okay, thunder arrestor or lightning arrestor. The earthing or grounding helps to send excess electricity that is coming from the national grid. Okay, so it sends excess current that is coming from national grid to the ground. It also helps to send excess current that occurs as a result of a breach or a malfunction of one of your own electrical appliances. So of one of your electrical appliances, okay, it helps to send the excess current that might be generated as a result of that to the ground. In an electric circuit, there are always three major components in an electric circuit. So the first component is the power source or the energy source, okay? Then the second component is the conductor, and the third one is the load. The power source could be a PV module or batteries, okay? Then you have the conductor and you have the load. So what is the load? The load is the electrical appliance that is connected to the power source, okay? The electrical appliance that is connected to the power source is the load. Then the conductor, what is the conductor? A conductor essentially is a cable that is used to connect that load to the power source. So now there are two different types of circuits. Though from the two different types of circuit, there are some connections you can do and you can get more than two different types of circuit. You can get 3 or even 4. Okay, but essentially there are two types of circuit, which is parallel circuit and series circuit. So now, and the rules to how you connect a series circuit or parallel circuit governs how you connect it, irrespective of what you are connecting, be it an electrical appliance, be it a battery or a power source. So whatever it is that you're connecting, the rules remain the same. Okay, so now we're going to look at the rules, what happens when you are connecting in parallel and what happens when you are connecting in series. Now let's look at the rules of series connection. Okay, so we start from series connection, so let's look at the rules. Okay, so rule number 1. So as an engineer, you should have it in mind that when you connect circuits in series, be it a battery, be it an inverter system, whatever it is, be it solar panels. So once you connect in series, so what happens is that the voltage becomes the sum total of all connected devices. So now let me give an instance. Let's assume we are connecting batteries in series. Now in this instance, we are going to use 4 batteries of 12 volts each and 200 amps each. Okay, so 200 amp hour 12 volt batteries, 4 units. So if you connect 4 units of this battery in series, the voltage automatically becomes the sum total of the 4 batteries voltage, which is 12 times 4. So that gives you 48. So the voltage automatically becomes 48. Okay, that's rule number 1. You should know when you connect in series, the voltage becomes the sum total of all connected devices. If it's a battery, it becomes the sum total of all connected battery. If it is a PV module, which is solar panel, then the voltage becomes the sum total of all connected solar panels. That's rule number 1. Now rule number 2, when you connect in series, just have it in mind that the current, the ampere, remains the same. So like in the instance I'm using, we're using a 4 units of 12 volts 200 amps battery. So when you connect that in series, the amp will remain 200. It doesn't matter if it is 68 batteries that you're connecting, it doesn't matter if it's 100 batteries that you are connecting, it doesn't matter if it is 25 batteries. As long as it is series connection, the current, which is measured in amps, will remain the same. Okay, that's that. Then the third rule that you should know in series connection is that if there is any problem with any of the appliance or that is being connected in series, it's going to affect the remaining appliances. So now in this case, we are using a battery. So if you connected 4 batteries in series and one of the batteries happen to have problem, let's assume the battery is dead. Okay, so if the battery is dead, if one of the batteries is dead, it's going to affect the performance of the whole system. In fact, it might not even work at all. Okay, so that's one of the things you should know about series connection. If you are doing parallel connection, if you are working on a parallel circuit, so now these are the 3 rules that guides connecting items in parallel. Rule number 1, the voltage, the total output voltage will remain the same irrespective of the number of connected devices. So now in this instance, we are also going to use 4 units of 12 volts battery with 200 amp hour rating. So if we connect these batteries, the 4 batteries in parallel, so what happens to the voltage? So since the batteries are 12 volts each and they are 4 and they are connected in parallel, the output voltage will remain 12. Why? That's rule number 1 for parallel connection. So as long as they are connected in parallel, the output voltage will remain exactly the same thing as what each individual battery is giving. So that's rule number 1. Rule number 2, the current becomes the sum total of all connected devices rating. Okay, so now in this case the rating is 200 amps for each battery. So since it is 4, since there are 4 units, so 200 times 4 is 800. So automatically the total current or the amp hour output becomes 800 for the 4 units of a 200 amp hour batteries connected in parallel. That's rule number 2. Now let's look at rule number 3, which is very critical. Remember, rule number 3 for series connection states that if there is any problem with any of the connected devices, it will affect the total output, meaning that the whole setup may not work. And not just that it may not work, actually can lead to a serious problem. Okay, but now in parallel connection, if there is a problem with one of the connected devices, the remaining devices will continue to work. Is that surprising? So that's one of the things that you have to consider. Okay, so if you connected batteries in parallel, you connected 4 batteries, and one of the battery happened to be dead. So one of the batteries happened to be dead. The remaining 4 will continue working, and you might not even notice it. So, but if you're smart, you will notice that the batteries are not lasting as long as it used to. So with regular checkup, you'll be able to identify that, oh, one battery is down. But if it was series connection, immediately one of the batteries have a problem, then forget it. The whole system will not function well. You notice that there's going to be a problem, there's going to be an interruption of service. Okay, so that's that. So right now we are going to look at the different units of measurement in electricity, which of course are widely used in solar system setup. So we are going to look at these different terminologies like DC, AC, voltage, kV, kilovolts, kilovolt amperes, kilowatts, kilowatt hour. So what do all these terminologies mean? What do they mean? So practically I want to explain the meaning of these things, and then also there are some of them that are very confusing, which some people used to confuse. For example, a lot of technicians think that KVA is the same thing as kilowatts. So if you ask them to provide a setup of, let's say, 5 kVA for you, if you ask them to provide a setup of 5 kilowatts for you, they might go ahead and provide a setup of 5 kVA for you, thinking that 5 kVA is the same thing as 5 kilowatts. So I am going to explain the differences between these two terms, and there are also other confusing terminologies that I am going to explain. So I'm going to explain the meaning of all these terms so you get to understand. Then after that, we are going to go into the session where we are going to discuss about some of those things that causes fire. So you must have seen a situation whereby there is fire outbreak in the solar setup. So some of the times the fire starts from maybe the roof, or it starts from where the inverter and the batteries are connected. So I'm going to break down for you what causes the fire and how to avoid this fire. Okay, so for now, let's get started with these electrical terminologies, AC, DC, volts, and all that. Okay, so now back to electricity. So there are two forms of electricity depending on the direction of the flow. So one, we have alternating current, also known as AC. So, and then secondly, we have DC, that is direct current. So now let's look at the different units of measurement for these currents. So we have voltage, we have watts, we have kilowatts, kilowatt hour. So let me explain the meaning and the differences between these two things, because sometimes when people see watts and they see kilowatts and then they see kilowatt hour, they get confused because it's looking like, okay, which one is watt, which is kilowatt, then what is kilowatt hour? And a lot of people think that kilowatt and kilowatt hour is the same thing, so they are not the same. So now let me break it down. Watt or wattage and kilowatt hour. Okay, kilowatt hour is shortened as kWh. Okay, so what's the difference between watts and kilowatt hour? So watt is an instant measure of electricity. Now it's an instant measure of the amount of electricity that is being produced or consumed. So that is watt. So now, for example, if I have a device and that device is rated, okay, let me use this as an example. This is a charger, is rated as 4 watts actually. So what does it mean? What it means that if I plug in this charger, it's going to be consuming 4 watts instantly. It's going to be consuming 4 watts continuously. It will be consuming 4 watts. Okay, now so let's look at kilowatt and kilowatt hour. Okay, so what is kilowatt and then what is kilowatt hour? So I've just explained watt as an instant measure of the amount of electricity that is being produced or consumed by an electrical device. Kilowatt is used to refer to the same watt in thousands. So if we say 900 watts, okay, then if we say 1000 watts, 1000 watts is the same thing as 1 kilowatt, because the term kilo means 1,000. So 2 kilos means 2,000. 10 kilo, 10,000. So 10 kilowatt is the same thing as 10,000 watts. Then there is kilowatt hour. So kilowatt hour is shortened as kWh. So what's the difference between kilowatt hour and hour? Now, a device that is rated as 100 kilowatt hour does not mean that if you connect it, it's going to start consuming 100 kilowatt instantly. Like I explained earlier, that if you connect this small charger, it's going to start drawing 4 watts instantly. Okay, so now what's the meaning of kilowatt hour? Kilowatt hour is a unit of measurement that is used to measure the amount of energy consumption over a period of time. Now this period of time is usually calculated based on an hour basis. So if they say that this device is rated as 100 kilowatt hour, what it means is that when you plug in this device, if it is an appliance that consumes power, if you plug it in, it's going to consume a total of 100 kilowatts in 1 hour. Then if it is an appliance that produces light, what it means is that you can, when you are running it, you must not connect appliances that will consume more than 100 kilowatt hour of energy in an hour. Okay, so what it means is that it can allow you to give out up to 100 kilowatts of energy in an hour. So what it means is that you cannot plug in a device that is rated above 100 kilowatt hour on it. Okay, so I hope this is very clear. So now let me just break it down again. So you have watts or wattage, you have kilowatts, and you have kilowatt hour. Watt is an instant measure of the amount of electricity that is being produced or consumed by a device. Kilowatt is just a unit of measuring the same wattage in thousands. Then kilowatt hour is a unit of measuring the amount of electricity that is being consumed or produced over a period of time. So the difference between kilowatt hour and wattage is that kilowatt hour is for measurement over a period of time, while watt is for instant measurement. Okay, so I think that's very clear now. So we move to the next item on the list. Since we just finished explaining the difference between kilowatt hour and watt, so now there's also another terminology which is usually being confused with wattage and kilowatt hour. Okay, now that term is known as kilovolt amperes, which is shortened as KVA. Okay,